All right, today we're in section 3.5, solving inequalities using multiplication and division. In example 1, we see some inequalities here that have division attached to the variable. So we solve these in the same way that we solve equations, by using inverse operation. So does everybody agree that division is attached to my variable? You agree? Okay, so what's the opposite of division? Multiplication. So I multiply each side by the inverse. Each side by 3. And m is greater than 9. I graph my solution on the number line. 9 goes in the middle. 8 and 7. And 10 and 11. Open dot on the 9 or closed?
Open.
Why?
Because
there we go. It's not equal to. It's not equal to, so it's an open dot on the 9. And does the arrow go right or left?
Right.
It goes to the right because it's greater than. All right, I want you to go ahead and solve the second one the same way. C over 10 is less than or equal to negative 7. Solving graph. All right, so you multiply both sides by 10. Very good. Multiply by 10. And C is less than or equal to negative 70. And we come down here and we graph our solution. Negative 70. What two numbers go to the left? Negative 71 and negative 72. Remember, the farther left we go into the negative, the larger the negative. Negative 69 and negative 68. All right, open or close dot on the negative 70. Close dot on negative 70. And left or right? Left. Less than or equal to. Now, in these next problems, now we're solving an inequality that has a negative number attached to the variable. And in this case, there's a rule that we have to learn with solving these. Anytime I have to multiply or divide by a negative number to solve, I must reverse my inequality. So what do I need to multiply both sides by to solve for x? I need to multiply by what? Negative 5 both sides. Because I had to multiply by a negative, I am going to reverse my inequality. Now x is going to be greater than or equal to negative 50. And then I graph my solution like normal. Okay? So the rule is to reverse the inequality if you have to multiply or divide by a negative. Negative 49, negative 48. Open or close dot? Close because it's equal to. And arrow going left or right? To the right. It's greater than. All right, I want you to solve the second one the same way. All right, so what do I multiply both sides by? By negative 4. Since I had to multiply by a negative, all right, now it's going to be 48 is less than x. But remember how I read it. I always read it the variable first to make sure that I graph it correctly. So I read it x is greater than 48. So here's my number line. 48 is my solution, goes in the middle. 47 and 46. 49 and 50. Open dot on the 48. And greater than. X is greater than 48. Did you reverse your inequality? Did you reverse it? Yeah? Okay, so remember, the reason you reversed it is because you had to multiply by a negative number to isolate the variable. Now, in example 2, it's more of the same thing. Solving an inequality, except now it's just a different operation because what operation is connected to the variable? Multiplication. So what do you have to do to solve? Divide both sides. So on the first one, we have negative 10t is greater than or equal to 40. I want you to go ahead and try to solve. If you're lost, that's okay. Raise your hand. I'll come help. Or just hang on for a minute and then we'll go over it. All right, so I divide both sides by negative 10. That's what's attached to my variable. Since I divided by a negative, what happens to my inequality? I need to flip it. So now t is less than or equal to negative 4. Your whole answer changes. So make sure you catch that. All right, divided by a negative, so I flip my inequality. Negative 4, negative 5, negative 6, negative 3, and negative 2. Open or close dot on negative 4. All right, and does my arrow go left or right? To the left, less than. All right, go ahead and solve the second one. 12x is less than negative 36. So I'm going to divide both sides by what? 12, both sides. And do I need to reverse my inequality? Did I divide by a negative to solve for the variable? I didn't. So even though there's a negative up here, that does not affect whether or not I need to flip my variable. Because I divided by a positive number to isolate x, I just leave my inequality alone. My solution is a negative, but nothing happens to my inequality. Does that make sense? Okay. The only time I mess with my inequality is when the negative is attached to the variable. Negative 2, negative 1. Open or close dot? What is it? It is open because there's no equal to symbol underneath the less than sign. So open dot, arrow going left for less than. Any questions? All right, one more. You know we got a word problem. Okay, so on page 144, let's read the geese migration example on the top of page 144. It says, some flocks of Canada geese can fly nonstop for up to 16 hours. In this time, a flock can migrate as far as 848 miles. At whatever speeds can such a flock fly during migration? Okay, there we go. Got it out. Okay, so what is my total mileage? How far can they go? How far can they go? 848 miles. That's my total. Okay, and they can fly up to how many hours? 16 hours, but I don't know the speed. Now, here's the word that I need to pay attention to. It says up to 16 hours, and they can fly as far as 848 miles. So, does it mean that they can fly more than 848 miles or up to 848 miles? Up to, okay? So, since it's up to, 848 is the ceiling, right? That's the most possible. So it's got to be what? Less than, but can they fly 848? So if 848 can be a part of the solution, it needs the equal to component. All right? So that's how we've got to break these down. We have to ask ourselves, can the number be a part of the solution? If it is, then it can be equal to. And then, is that number the ceiling? Is it the absolute most? If it is, it's less than. Or is it the least or the lowest number? If it's that, then it's going to be greater than. All right, and then I can just solve it by dividing both sides by 16. And what's 848 divided by 16? So S is less than or equal to 53 miles per hour. Just to clarify, that's very unrealistic. All right, I doubt a goose can fly 53 miles an hour. That would be like crazy to see. Okay, anybody ever seen a goose like walk? They're so slow. All right. Okay. All right, guys. If you understand that, that's everything you need to know for 3.5.